Hello, my dear students. Our lesson today, Unit 3, Lesson 3, Follow Reflection. The axis, the axis of symmetry of some geometric figures. Number 1, parallelogram. Parallelogram has no axis of symmetry. Trapezoid has no axis also of symmetry. And scalene triangle has zero axis of symmetry or no axis of symmetry in parallelogram, trapezoid, and scalene triangle. But in isosceles triangle, I have one line of symmetry. Also in as isosceles trapezoid has one line of symmetry. Okay? In a rectangle have two lines of symmetry. In a rhombus has also two lines of symmetry. But in equilateral triangle, I have three lines of symmetry. Square has four lines of symmetry. In a regular pentagon, I have five lines of symmetry. In regular hexagon, I have 6 lines of symmetry. We studied all of them before in grade 4 and 5, right? Okay, now exercise determine the number of axes of symmetry of each figure below. Number 1, this is the isosceles triangle, so the axis of symmetry is 1. Another one, it's equilateral triangle, so how many axes of symmetry? It's 3. Number 3, or figure number 3, it's a rectangle. How many axes of symmetry? 2. Number 4, it's a square. How many axes of symmetry? 4. Number 5, it's a rhombus. How many axes of symmetry? 2. The last one here, it's isosceles trapezium. How many axes of symmetry? 1. Example in the opposite figure, triangle ABC is an equilateral triangle where DE and F are the midpoints of AB, BC, and AC respectively, and AE intersection with BF intersection with CD at M. Complete number 1. Axis of symmetry of this triangle is, this is an equilateral triangle, so has 3 axes of symmetry, and its name AE, BF, and CD. Number 2, AB is the reflected image of AC by reflection in AE. AB is the reflected image of AC by reflection in AE. Number 3, the reflected image of AF by reflection in BF is CF, and the reflected image of CF in AE is BD. The reflected image of triangle AMD by reflection in AE is triangle AMF. Okay, the reflected of AMD is AMF. Then measure of angle AMD equal measure of angle AMF, because the reflection in a line reserves the measure of the angles. Okay, the reflected image of triangle AMB by reflection in AE is triangle AMC. Reflection around the point. Reflection in a point M, map each point A in the plane to the point A dash in the same plane where M is the midpoint of the line segment AA dash. The point M is called center of reflection in the image of M by reflection in M is itself. Okay? Now find the image of a point by reflection in a given point. To find the image of a point A by reflection in M, we do as follows. Number 1, draw AM as a ray. Okay. Number 2, using the compass with a reduced length equals MA, then use M as the center and draw an arc to intersect AM at point A dash, as this. Then A dash is the image of the point A by reflection in the point. From the previous we found that MA equal to MA dash. Now find the image of a line segment by reflection in a given point. To find the image of a line segment A, B by reflection in M, we do as follows. Find the image of A by reflection in M to be A dash as we mentioned before. Similarly, find the image of B by reflection in M to be B dash. Draw AB to be the image of AB by reflection on the point M. We note that AB dash equal AB and AB dash parallel to AB. Reflection around a point. Reserves the length of the line segments. Reserves the measures of angles. Reserves the parallel property. There is for a reflection in an isometry. Reflection in the original point. In the point C is a point of the Cartesian coordinating plan where C 2 and 3. To find the image of the point C by reflection in the original point O using the same previous method, we will find it C dash negative 2 and negative 3. So now we have a new rule. The image of the point X and Y by reflection in original points, we must change the sign of X and Y coordinating. It's become negative X and negative Y. Now exercises the image of the point X and Y by reflection in original point, negative X and negative Y. Number 1, 2 and 3 by reflection in original points, it's become negative 2 and negative 3. Number 2, negative 4 and 1 reflection in original point, we change the sign of X and Y. Negative 4 become 4 and 1 become negative 1. Number 3, 5 and the negative 2 changes the sign of the two coordinating. 5 become negative 5 and negative 2 become 2. So remark here the image of the point 0, 0 by reflection in original points, it is itself. Exercise triangle ABC where A negative 2 1, B 4 negative 3 and C 2 and 3. Then complete A negative 2 and 1 reflection in original. So we change the sign of X and Y. A dash become 2 and negative 1. B 4 and negative 3 also change the two coordinating. 4 become negative 4, 3 negative 3 become 3, and C C is 2 and 3. Okay, so the reflection in the original equal negative 2 and negative 3. Now we will draw the points A, B, and C. A negative 2 and 1. B 4 and negative 3. C 2 and 3. and connected all the points. This is the original A, B, C. And reflection this original point to become A dash to -1, B dash -4 and 3, C dash -2 and -3. Connected the points, and this is our drawing. The last questions. Exercise, choose the correct answer. Number 1, the image of the point -3 and 2 by reflection in the original point is change the sign of x and y, so it's become 3 and -2. The point 5 and -2 in the image of the point what by reflection in the original point, so the answer will be also change the sign of x and y, -5 and 2. The points whose image by reflection in the original points it's itself, so it's called 0 and 0. The image of the points 3 and -2 by reflection in the original points formed by reflection in x-axis. Oh, so here the x-axis still as the same and only change the y-axis, so the answer will be 3 and 2.